Hi all, in this video we're going to look at more examples that on integration. The examples we're going to look at today are going to focus on integrals that involve the use of trig identities or trig ratios. So we're going to sample through a few here and then we'll work them out and see how I would approach them. If you have an easier way of doing it, let me know in the comment section so that we can compare our notes. So let's look at the first one there. In the first one, we're looking at the integral of sine squared theta, cot theta, then we have cos to the power 3 theta, d theta. So here I'll start by focusing on the cot there. Then of course I want to recall that cot theta is the same as cos theta over sine theta. So using that there, we now have sine squared theta over, when I put cos over sine and multiply with the cos to the power 3, becomes cos to the power 4 theta over sine theta d theta. Single fraction there implies that I am now looking at the integral of sine to the power 3 theta over cos to the power 4 theta d theta. At this stage, I can split the sine in the numerator, presenting it as sine squared theta and sine theta over cos to the power 4 theta d theta. Then I can use the identity for sine squared theta being equals to 1 minus cos squared theta. In this way, now I have 1 minus cos squared theta multiplying sine theta in the numerator divided by cos to the power 4 theta d theta. So I did it like this so that when I let my u to be cos theta, this sine theta will get to cancel with the sine that will come with the d theta there. So let's make that substitution. Let u be equals to cos theta. In this way, du d theta will be equals to negative sine theta. And when you make d theta the subject of the formula, you're going to have negative du over sine theta. Substituting now, you now have the integral of 1 minus, since sine theta is u or cos theta is u, this will be u squared over, this will be sine theta still, and this will be u to the power 4. Where there's d theta, we have minus du over sine theta. When you simplify, the negative leaves the root, leaving us with 1 minus u squared, and then this and this will cancel, leaving us with only u to the power 4 here, du. Then from here we see that we can approach this as 1 over u to the power 4 minus, then this becomes u squared over u to the power 4, this becomes 1 over u to the power 2 du. So now we have two basic integrals. One is u to the power minus 4 du, and the other becomes plus the integral of u to the power minus 2 du. When we integrate here, the minus will cancel with the minus, leaving us with 1 over 5 u to the power 5 minus 5 as well. Here the minus will show up, but it will be u to the power 3 minus over 3 as well, then plus c. So just counter check. This becomes a 5. The minus makes this positive. The 5 divides as well. This becomes, sorry. So be very careful of the mistakes here. Remember, when integrating, we are adding to the power, but adding to minus 4, it becomes minus 3. So to minus 4, when you add 1, it becomes minus 3. So this will actually be minus 3, and this will be a 3. And to the minus 2 there, when you add a 1, it becomes minus 1. So be very careful there. It's very easy to make a mistake here. So this is what you end up with. So that in the end, you have 1 over 3 u to the power 3 minus 1 over u to the power 1 there plus c. But remember, u is cos theta, so this becomes 1 over 3 cos to the power 3 theta minus 1 over cos theta plus c. So this becomes the overall solution there. Let's pick another one so that we see how we would work it out. Another problem that we can work out here is going to be sec to the power 3t tan to the power 3t dt. So most of these, as I pointed out, involve just the use of tricks to work them out. So as usual, we do classes every night. Online classes. So if you're interested, reach out to me using the number +260 979 38 28 1. So reach me through WhatsApp if you're interested to join the WhatsApp group, so that you join in the live classes for questions and so on. More practice every night. Okay, so let's see how you'd work out this one. For this one, again, is just a trick that we're going to use here. So here we'll use the fact that if you differentiate sec with respect to any variable, let's say sec theta, the answer will be sec theta tan theta. So here, based on that, we'll split this so that we look at it as sec squared t, and then we'll split the tan as well so that we look at it as tan squared t, and then we'll isolate one of the sec terms and one of the tan terms, dt. Once we've done that, since what we want to differentiate is sec t, so change this tan so that it becomes a sec. So here we know to say if we have tan squared theta will be equals to, that is going to be sec squared theta minus 1. So based on that, we're going to make the substitution so that now we have sec squared t multiplying sec squared t minus 1. And then this side is to have sec t tan t dt. Once we're here, we can proceed. You can distribute, but you can still proceed from here. But if you distribute, of course, this is going to be sec to the power 4t minus sec squared t. And then this side, you still have sec t tan t dt. So here now, we let u be equal to sec t. So now when we differentiate u with respect to t, this will be equal to sec t tan t, and then from here make dt the subject of the formula, becomes du over sec t tan t. And then when you make the substitution, I see sec to the power 4, so that is going to be u to the power 4 minus sec to the power 2, so that will be u to the power 2. And then this one here will not make the substitution because we are reserving it for the dt there. So it will be sec t tan t, and then where we have dt, we'll put du over sec t tan t. We see that the sec t tan t and the sec t tan t there will cancel out, leaving us with the integral of u to the power 4 minus u to the power 2 du. Then we integrate here, add 1 to the 4, making it a 5 over 5 minus, this becomes u to the power 3 over 3 plus c. And recall that u is sec t. So u is sec t, implying that our solution is sec to the power 5t over 5 minus sec to the power 3t over 3 plus c. So this becomes our solution here. Another problem that we can work out very quickly here is going to be e here. So e, we're looking at the integral of sine to the power 7 theta d theta. So what trick are we going to use here? So to work out this one, I'll split so that we have sine to the power 6 theta and sine theta d theta. Then here we'll look at this one as sine squared theta to the power 3, and then we have sine theta d theta. Then we use that identity for sine as well, presenting sine in terms of cosine as 1 minus cos squared theta to the power 3 sine theta d theta. Then here we'll let u be equals to cos theta, so that du d theta will be negative sine theta. This of course will imply that d theta will be equals to negative du over sine theta. When we make the substitution now, we're going to have 1 minus u squared, of course, raised to power 3 as well. Then sine theta, where we have du, where we have d theta, I mean, have du over sine theta there. The sine theta and the sine theta will cancel. The negative comes first. So now we have 1 minus u to the power 2 to the power 3 du. And then from here, to integrate this, of course, we're going to expand first. And when we expand that part, it ends up becoming that expression there. So that is what we end up getting. So we can expand this slowly if we want. We can use any method to expand this. We can use Pascal's triangle of coefficients and the likes. Or you can just look at it as 1 minus u, that multiplying itself 3 times du. So from there, if you did that, what would you get? Let's do it just a bit, and then of course we'll see how it reduces to that expression in red. So if we did that, we're going to have first, we'll multiply the first part, so this will be 1 minus u squared. Basically, I can do this a little bit faster. But if we do it a little bit faster, this is going to be minus 2u, and then this is going to be plus u to the power 4 there, multiplying 1 minus u squared there, du. And then finally, we'll do the last pair now, minus 2u plus u to the power 4, then minus u squared, then plus 2u to the power 4, then minus u to the power 6 there, du. So we end up in this expression. And now when you simplify a little bit, this simplifies with this to give us this. This simplifies with this to give us this. And the minus that remains like that. So of course we just have a negative this side. So now when we integrate, we'll have minus. This will be u here, minus. So this will be 3 over 3, which is just going to reduce to a 1. Then u to the power 3. Then plus, this becomes a 5. So it will be 3 over 5 u to the power 5 minus. Then this will be u to the power 7 over 7. Then plus c. Recall what u is. We said u was what when we started. We let u to be cos theta. So our expression will be minus cos theta. This becomes plus cos to the power 3 theta plus. This becomes minus when the negative multiplies. 3 over 5 cos to the power 5 theta. This becomes plus. They have cos to the power 7 theta over 7 plus c. Okay, so this is how this one would end up. Okay, so I think this one will end here. There are more problems that are there. So we'll see in the next video. We'll do a few more as well. But in the meantime, you can try them out. Let me know what you get to find. You can send me your solutions. And if you maybe approach these questions a different way and you'd want to just let me look at it, you can send me your solutions again to the same number. Not 9 plus 2, 6, 0979 38 28 1. So send me your solutions on WhatsApp. Let me know what you think and which questions you want me to look at next. We'll see you guys in the next class.